Hello everyone, welcome back to the course on construction methodology. So in today's class, we are going to see what is a transit mixer, what are the different capacity of the mixer that is available at the site, what are the quality controls that a young engineer has to do, and what are the certain tips how an engineer has to work at the site. So we'll try to see those things one by one. So this is how a transit mixer looks, right? So we call this as a rotating drum. And I hope you guys have seen this. You can always see a concrete transit mixer with this rotating drum always in a motion. And these are the different capacities of the transit mixer that is available. We have 3M cube, we have 4M cube capacity, we have 5M cube capacity, we have 6, 7, 8, 9, and 10. So these are the different capacities of the transit mixer that is available at the construction industry. So the one question that always strikes our mind is, what is the point in keeping this rotating drum in motion? So the idea behind this is, we know that when the concrete is in motion, it's not going to set easily. What I'm trying to tell is, when the concrete is inside this rotating drum, the chances of the concrete getting set is very less. So because of that reason, what we are going to do, we are going to keep this rotating drum in motion. That is the first reason. The second reason is that a concrete comprises of coarse aggregate, fine aggregate, and cement. So look at the shape of this rotating drum. It is something inclined, right? So if I don't keep this in rotation, what is going to happen? Coarse aggregate is a heavier material compared to fine aggregate and cement. So what will happen? Your coarse aggregate will be somewhere here, and cement paste and fine aggregate will be somewhere here. As a result of that, we're not going to get a uniform mixture. So in order to get a uniform mixture, what we are going to do, we are going to keep this rotating drum in motion so that it keeps on rotating and there is no segregation. That is the coarse aggregate doesn't get separated from the fine aggregate and the cement, so that you're going to get a uniform mixture. So that is the main idea behind keeping this transit mixer drum in motion, or you can call it as in rotation. So we'll see this is how it looks. So we have to this is how it is rotating whenever it is in motion. And this is a footing schedule plan that we are going to see. So when you're working in a big projects, you will be given certain task or certain target per day. So this much number of footing has to be casted per day. So planning engineer will do a planning based on the schedule that he has prepared, and based on that he is going to give a target that per day you have to do this much amount of footing casting. So we'll try to understand it. So imagine on 23rd of October 2020 you're going to start your footing casting, and on 22nd of November 2020 you have to finish the casting of the footing. So imagine you're working in a very big project and you have 480 footings to be completed. And what is the time duration that you have? You have only 1 month to finish it, right? 23rd October you have to start, and 22nd of November you have to finish it off. So you have hardly 30 days and you have to cast 480 number of footings. If this has to be achieved, what is the per day target? It's very simple mathematics again. 480 divided by 30, that is number of days. If I'm doing, I'll get 16 numbers. That is per day I have to do a casting. That is, I have to do 16 footings of casting per day, so that by the end of 30th day, that is by end of 22nd November, I'm going to finish all 480 footings that is present in my site. So we'll try to see what is the application of this. So these are certain tips for the young engineers. So once all the footings are ready to be casted, we will calculate the required quantity of concrete from the RMC plant to be ordered. That is, imagine you have to do 16 footings per day. So for doing 16 footings per day, you need to calculate the quantity of concrete that is required. So how much quantity of concrete is required, that we are going to do the calculation, and based on the amount that we are going to get, we are going to place the order. Now, for example, let us consider we need X amount of concrete, and X amount of concrete we are going to order. So next is the number of footing to be casted per day will be given by a planning engineer, and as a site engineer, it is your duty to get it done, as I already mentioned this point. So once the RMC truck, that is a transit mixer, reaches the site, make sure the invoice means the bill, is checked from the driver regarding the quantity and unit weight of the concrete. So what is the meaning of this? We'll try to understand this. So a quality engineer must check the weight of the truck by weighing it on the weigh bridge and make sure ordered quantity is reached on the site. So when you work in big projects, as I mentioned, you'll be having an engineer who is called as a quality engineer, who will be checking all these things, the weight of the concrete that is arriving at the site and all these things. So this is how it is. So So you ordered a transit mixer and this is a weigh bridge. So here you're going to get the weight of this vehicle and you have a small control room here. So you'll get all the information like what is the total weight of the vehicle, what is the empty weight of the vehicle, and you're going to get what is the concrete that is there, what is the amount of concrete that is there inside this rotating drum. All this information we are going to get it through this control room. So this is how it looks. So this is called as invoice, or you can call it as a bill. And so this is a loaded weight, that is this is a weight of the vehicle that has arrived now. Like say it is 28,080 kgs of weight of the vehicle, that is it has its own weight of the vehicle plus the weight of the concrete which is present inside the transit mixer. So this is the empty weight, so this is the only the weight of the transit mixer, that is 11,120. So what we want now, we want to find the weight of the concrete that is arrived in this vehicle. So the calculation becomes very simple. Loaded weight minus empty weight is going to give me the weight of the concrete, that is 28,080 minus 11,120. If I'm doing, I'm going to get 16,960 kg. So this is the weight of the concrete that is present inside the vehicle. So we'll try to understand in a more better way. So so we know that from the simple physics, we know that density is equal to mass by volume. So if the weight of the concrete is 60,960, from where did we get this? So this is a given. This was given by that control room. From there we have got this invoice. So it is mentioned as it is the weight of your concrete is 16,960. So if weight of the concrete is 16,090 kg, what is the volume that we ordered? Again, it's a simple calculation. We know that density is equal to mass by volume. I know the density of concrete is 2,400 kg per cubic meter, or you can call it as 24 kilonewton per cubic meter. So I need to find the volume. So if I want to find the volume, then what I have to do? I have to multiply it by, I have to divide it by mass divided by density. What is the mass? I know the weight of the concrete is 16,960 divided by unit weight of the concrete is, that is concrete density is 2,400. So if I'm doing this, I'm going to get 7 point something. I've made it as 7 m cube. That is 7 m cube of concrete I have ordered through this truck. So I'll put it the other way around. Suppose if you had ordered 7 m cube of the transit mixer, suppose if you ordered 7 m cube of the concrete, and what weight should you get there? Again, it's a very simple calculation. I need to find the weight. I know what is the density of the concrete, that is 24,000 kg per cubic meter. And I know that I ordered 7 m cube of the concrete. So the calculation is very simple. 2,400 into 7, if I'm going to do, I'm going to get 16,960. It comes out to be 16,800, 800 something. So we have taken 16,960 because it should have been 7.00 something. So I'm taking a almost a round figure of 16,960 is the weight of the vehicle. So which we are going to get as a cross check to this. So this is how I'm going to say, right? I need 16,900 kg. That is what I got from the control room. I mean, from the in the invoice, it is written as 16,960. And the simple calculations I have done, if I ordered 7 MQ of the concrete, and if the weight, if the concrete density is 2,400 kg, what is the value that I should be getting? It is 16,960. The same is written here. So these are the certain checks that we need to do, so that what will happen? We'll get an idea what is the amount of concrete that we have ordered and what is the amount of concrete that is actually arrived at the site. So sometimes what happens, you'll be ordering 7 MQ of the concrete, but by the time it reaches the site, you'll be getting a very, you'll be getting somewhere close to 6 or 6.5 MQ of the concrete, right? So all these things will happen at the site. So it's always a good thing, or I would say it's a good thing to check all these things so that you don't go wrong anyway. So this is how it is. So you order a transit mixer, it will come to a site. And as I always mentioned, before the concrete is placed, the transit mixer drum is rotated for 1 or 2 minutes so that the mix is uniform and segregation is not there, right? So as I mentioned, whenever a transit mixer arrives to a site, you have to make sure this rotating drum is rotated for 30 to 1 second, 30 second to 1 minute, so that you'll get a uniform mixture of the concrete and there is no segregation in this concrete. That means your concrete, aggregate is somewhere here, your cement paste and fine aggregate is somewhere here. That shouldn't happen. You should get a uniform mixture. So only then you're going to get a good quality of the concrete. So let's say that today's task is 16 footing to be cast, that we already seen, right? A planning engineer has given that you have to meet your target, that is you have to do 16 footings per day. So taking that into consideration, so my target is to do 16 footings per day. So and imagine the size of the footing is 2.5 meter by 3 meter by 450 mm. So we can make it as 0.45 meter. So this is the size of one footing, and imagine the size of all 16 footing is same, 2.5 into 3 into 450. So what is the concrete that is required? So it's again simple calculation. I need to find the volume of the concrete. So volume will be length, that is 2.5 into 3 meter into 450 is mm. I need it in meters, so I convert it to meter and I have written it as 0.45. So this was for one footing, right? How many footing I have to do for per day? 16 footings. So into 16 I'm going to get 54 m cube is the concrete that is required to cast the 16 footings. So imagine you're placing order and he has only 6 m cube of vehicle at him at present. So what are you going to do? So if 6 m cube is the capacity of single truck, so for 54 m cube of the concrete, how many trucks is required? So I require 9 RMC truck to be ordered. So this is how we are going to do the calculation. And now concentrate here. So also order the transit mixer one after the other without any delay. So what do you mean by that? Imagine you want to do a 16 footing casting, and you know that within 3 hours you can finish it off. So in order to finish it within 3 hours, you should be ordering the transit mixer one by one. Right? Imagine once a transit mixer comes to the site, it's going to take 10 minutes for unloading. That is, it will come, it will do all this work by casting the footing, then it's going to leave the site. So all this process is going to take 10 minutes. So once the 10 minutes is done, once the single truck has done its work, the next truck should be ready in line so that the work that you have planned for 3 years is going to get finished by 3 years. Otherwise, if you're delaying it, like one vehicle comes and after 10 minutes, and after another 20 minutes, the next vehicle is going to come in, then what is going to happen? The work which you had planned for 3 hours is going to take 4.5 or 5 hours. Like you're actually delaying your work. So that should not happen. So what you have to do when you're placing the order, you should make sure the vehicle takes minimum 10 minutes to finish the work, and the next vehicle should be ready at your side so that there is no delay in the casting of the footing. So these are certain tips I've given to you so that whenever you guys work in the site, you don't make all these mistakes. And keeping this in mind, you can do the work in a very smooth way. So thank you, and we'll see you back in the next video.